This is 1981 AP Physics B question on geometric optics. And the problem states that an object O is placed 18 centimeters from the center of a convergent lens of focal length 6 centimeters as illustrated in the image. On the illustration, sketch a ray diagram to locate the image. So here, on the illustration above, sketch the ray diagram to locate the image. So for the image, again, we'll follow the rules for the ray diagrams. At first, it's going to be the ray that is parallel to the axis. So the rays, again, they go in all different directions, and we're looking at certain rays. So at first, it's parallel to the axis, and then until it reaches the lens. And then after that, it goes through the focal point. The second ray is going through the focal point and then parallel to the axis. And the third ray would go through the center. And the one that goes through the center doesn't bend, so it goes always straight. And the image, the image of the object is going to be formed where they intercept. So this will be the image of the object. And so that was the first question, where they wanted you to illustrate the diagram for the rays. And for the second question, they say, is the image real or virtual? And explain your choice. So the image is formed where the rays meet in real life, so they're not like virtual rays, not appearing waves. So the image is real, and it is inverted. And also all the images that are inverted, usually real ones. And another explanation of the real image would be if you place a screen in the place where the image is appearing, then you would be able to see the image on the screen because the rays meet at that point. For the next question, they say, using the lens equation, compute the distance of the image from the lens. So for the lens equation, I have 1 over the focal point is equal to 1 over the distance to the image plus 1 over the distance to the object. And the focal point is 6 centimeters. Again, I don't have to convert centimeters into meters here because my result is going to be just in centimeters. So I have 1 over 6 equals 2. And the object is placed 18 centimeters from the center of the lens, so the distance to the object is 18. And I'm looking to I'm searching the distance to the image, so the distance to the image. I can times them all by 18, common denominator in this case, and that will give me 18 times 1 over 6 gives me 3, equals to 18 over 18 gives me 1, and 18 times 1 over di gives me 18 over di. Then if I subtract 1 from both sides, I will have a 2 equals to 18 over di. So di is equal to, and again my result is going to be in centimeters because I did not convert it into other units, is going to be 9 centimeters. Now they're saying that a second convergent lens, also of focal length 6 centimeters, is placed exactly 6 centimeters to the right of the original lens as illustrated in the image. And they want you to find or illustrate on the graph, sketch the ray diagram to locate the final image that now will be formed and clearly indicate the final image. Our ray diagrams, we have again parallel through the focal point, and the focal point is the center of the second lens, so the ray is not going to be refracted. And then the next ray was through the focal point, and then parallel. And when it goes parallel, it has to go through the focal point of the other lens, so it's going to be going that direction. And then the one that goes through the center passes through the first lens without being refracted. But when it reaches the second lens, it will be refracted, since it went through the focal point of the second lens, because this point is the focal length of the second lens. It will go parallel afterwards. So the image is going to be formed in this position. And if the second lens was placed after the first one. And that is all I have for this question 1981 that was in FRQ part of AP Physics B, which is now part of AP Physics 2. And thank you for watching, and I'll see you in the next video.